June 28, 1945. A factory floor in Ypsilanti, Michigan, 300 feet wide and more than half a mile long. The last B-24 Liberator heavy bomber rolls off the Willow Run assembly line for the final time. 42,500 workers have kept this building running 24 hours a day for 3 years. At peak production, the men and women inside finish one completed 4-engine bomber every 63 minutes. In August 1944 alone, they built 428. Ford produced 8,685 B-24s at Willow Run, more bombers than any other single manufacturer in the war. The plant itself was 3.5 million square feet, more than 3,200 feet long, a building so large that fog formed inside it on cold Michigan mornings. At the same time, Ford's River Rouge complex produced 57,851 aircraft engines, 7.2% of the entire American wartime output, alongside GPW military jeeps, M4 tank power units, and armored carriers. The Army Air Force eventually ordered Ford to slow down. Combat losses had not matched the projections. There were more bombers on the ground than the war could put into the air. The production line had outrun the conflict it was built to serve. On June 28th, the last B-24 rolls out the Willow Run doors. The workers go home, the engineers go home. 3 years later, those same engineers sit down to design a farm truck. The engine they built was not designed for a farm. It was engineered by men who had spent 4 years working to a standard where a failed component does not produce a warranty claim. It produces a dead crew at 40,000 feet. They could not build to a lower standard simply because the application changed. Building at the pace of war does not leave a tolerance for sentimentality about design shortcuts. Ford built this engine for a war that had already ended. Farmers have been running it ever since. When a production line builds to bomber tolerances for 4 years, those tolerances become the only tolerances the people on that line understand. You do not downshift your precision standards because the application is less dangerous. You build what you know how to build. If you've worked on one of the trucks that carried this engine, or know someone who has, drop the year and the platform in the comments, and subscribe to American Motor Files for the engineering history the industry never put in the press release. There is a Ford F-350 sitting on a working farm right now, not in a garage, not on a trailer, with 431,000 miles on a V8. The farmer who owns it has never had the heads off. He does not know this engine was designed by men who had just finished producing bombers at a rate that embarrassed the entire aerospace industry. He just knows it starts, in January, without hesitation, in a shed that does not have heat. That truck is not a restoration project. It is pulling weight on ground his grandfather broke, running on mechanical principles that have not changed since the day it left the factory. No computer interrogating the injection pump. No sensor array deciding whether the next cold start is authorized. No dealer port required to diagnose what makes noise under the hood. An iron block, a mechanical fuel system, and tolerance standards set by engineers who learned their trade under conditions where a bad casting decision costs 10 lives and a mission. The mechanic who last worked on it charged $80 and did the job in a gravel driveway with hand tools. There was no scan tool involved. There was no software update required before the truck would run. That is not nostalgia. That is a design specification. If you have ever worked ground with a Ford truck parked at the edge of the field, you already know which engine this is. You have heard it pull from idle without announcement. You have felt the torque arrive at 1200 RPM, unhurried, without asking for acknowledgement. You have watched it pull a load that would have put a modern engine into limp mode and driven away clean. You have listened to it start in cold that would have killed a battery-dependent system before it turned over once. What you may not know is the specific sequence of events, a specific war, a specific shortage, a specific delay that put that engine under that hood. Here is what the documents confirm, and here is where interpretation is required. No government specification sheet designates this engine a military-grade design. Ford never sold it that way. No military procurement contract in the public record required the F-Series 588 to meet a military performance standard. What the documents do confirm is this. The 1948 Ford F-Series, the first American commercial vehicle designed from scratch after World War II, was built by engineers who had spent 4 years working to a completely different standard than any farm truck required. At Willow Run, Ford built 8,685 B-24 Liberators, almost half of every Liberator produced by any manufacturer in the entire war. At Ford's River Rouge plant, workers produced 57,851 aircraft engines, 7.2% of the entire American wartime output. Ford's factories also produced GPW military jeeps, M4 tank power units, armored carriers, and military trucks in volumes the Army struggled to absorb. The Army Air Force, in 1944, ordered Ford to deliberately reduce B-24 production because planes were rolling off the Willow Run line faster than the war effort could crew and deploy them. These are the engineers who, 3 years later, sat down to design the 1948 F-Series. When Ford spent $1 million on the cab alone, a figure so extraordinary that marketing built an entire campaign around it and called the result the $1 million cab. The men designing the frame, the axles, and the engine underneath were applying the only manufacturing culture they understood. Whether the resulting truck constitutes a vehicle built to military standards depends on how you classify the people who built it. What it produced was a truck that outlasted almost everything designed alongside it. The 1948 F-Series ran from the F1 half-ton to the F8, which handled payloads exceeding 21,000 pounds. The chassis incorporated suspension geometry and axle specifications derived directly from what Ford engineers had proven building and testing military vehicles under sustained load conditions no civilian buyer would ever replicate. Veterans returning from service had given Ford's design team direct feedback on what a truck needed to survive sustained heavy use. The team didn't interpret that feedback as a wish list. They treated it as a specification. The veterans, who had driven GPW Jeeps across Europe and the Pacific in conditions that would destroy a civilian vehicle in a week, had specific requirements. Frames that didn't flex under load, axles that didn't fail in mud, engines that started when it was 30 below and still ran when it was 110. Ford's engineers wrote those requirements into the F-Series. The engine in those first trucks was the Flathead V8, proven in wartime service, already reaching the limit of its development potential. Ford's engineers were already working on what came next. The replacement engine was ready for 1953. Ford planned the introduction for the company's 50th anniversary. The Korean War made that impossible. Military demand had consumed enough of the national nickel supply that Ford could not manufacture the new V8 in sufficient quantities for a full production launch. The debut shifted to 1954, not by design, not by engineering preference, but because a conflict on the Korean peninsula had consumed the raw material Ford needed to build the next generation of American farm trucks. That forced delay produced something Ford had not planned for. The 1954 Y Block V8 displaced 239 cubic inches, the same as the Flathead it replaced, but delivered 130 horsepower compared with the Flathead's final output of 110, an 18% increase at identical displacement and nearly identical weight. It also delivered 193 pound-feet of torque. The overhead valve design gave it a larger bore and a shorter stroke than its predecessor, reducing internal friction at operating temperature and extending service intervals. Ford engineers added full-pressure oil filtration, shaft rocker arms, staggered oiling at the connecting rod journals, and a dedicated timing chain lubrication circuit, features not previously found on a Ford production truck engine. The deep-skirted cast-iron block, which gave the engine its Y-block name when viewed from the front, added rigidity at the crankshaft that the Flathead's narrower skirt did not provide. That rigidity mattered on a farm, where the engine runs at sustained load under conditions that a passenger car engine never encounters. Chevrolet introduced its 265 cubic inch small block V8 in 1955. Chevrolet had not taken the extra year. The 1955 Chevrolet 265 shipped with documented first-year warranty problems that followed it into the dealer network for months. The Y block had no equivalent problem. The Korean War, by delaying the Y block's debut, had handed Ford 12 months that General Motors spent rushing a competitor to market. The Y block was so well suited to sustained work that Ford of Brazil kept it in production at the Ipiranga plant in Sao Paulo through the early 1980s, nearly 20 years after Ford discontinued it in the United States. A farm truck engine, still being produced for working vehicles in South America, long after the engineers who designed it had retired. The Y block had one documented design flaw. Ford never corrected from the factory. The oiling circuit at the rocker shafts carried a restriction between the center cam bearing and the cylinder head, a passage offset and undersized for sustained high output use. The low detergent, high coke motor oils of the 1950s made the problem worse over time, allowing deposits to accumulate in the already undersized passage until oil flow to the rocker shafts dropped below what the components needed. The engines that ran long intervals between oil changes and never received a solution developed premature top-end wear that showed up as valve train noise after 40,000 miles. Mechanics found a solution. The engines that received it are still running. The engines that did not are in fields. Ford retained the Y block in its truck lineup through 1964, 2 full years after discontinuing it in passenger cars. It left the cars in 1962. Ford kept it in the farm trucks specifically. That mileage figure, 431,000 miles on a V8 with the head still on, does not fit the story most people have been told about what American trucks were built for. Which part changes how you look at the engine in your memory, that it survived, or that the war that delayed it also hardened it? The FE engine family that replaced the Y block in 1958 ran 18 years. Within that family, Ford built a dedicated truck variant called the FT, Ford Truck. The 360 cubic inch FT was never installed in a passenger car. At no point in its production run was it available in a Ford or Mercury sedan, coupe, or wagon. Ford designed it for the F100, the F250, and the F350, and for government fleet procurement that ran from the same production line as the civilian farm truck order placed at any Ford dealership that year. Federal agencies, municipal fleets, and private farmers ordering the F250 in 1970 received the same 360 FT block, cast in the same foundry, machined to the same specification. By the late 1960s, the FT variants, 360 and 391 cubic inches, were the most common power plants in surviving Ford F-Series trucks from that decade. If you drove a Ford work truck through the 1960s or early 1970s, the odds are strong you were running an engine Ford never sold to the public in any other application. Only in a work truck, only on a farm, or a job site, or a government lot. Nowhere that required leather seats or a chrome badge. The FE and FT left the truck lineup between 1975 and 1976. Emissions recertification under the new SAE net measurement standards had made the older architecture increasingly difficult to run. What replaced it had been in production since 1968, not in a farm truck, in a Lincoln Continental. The 460 cubic inch 385 series V8 debuted in the 1968 Lincoln Continental. Mark III at 365 horsepower and 485 pound-feet of torque. The block was cast iron. The main bearing journals measured 3 inches across. The assembled engine weighed 720 pounds. When the 460 entered the F-Series in 1973, it arrived in a vehicle class where 720 pounds of cast iron was a structural advantage, not a liability. By 1977, federal emissions equipment had reduced the rated output to 197 horsepower, a 46% reduction from the 1968 peak, on paper. The farmers running these trucks in 1977 did not read the press release about the output reduction. They noticed the truck still pulled. The torque behavior under sustained load, the property that matters at idle with 12,000 pounds of trailer behind it on a wet grade, did not change in the way the horsepower figure suggested. In the early 1980s, while the Corvette produced 190 horsepower and the Mustang produced 120, the Ford F-350 with the 460 produced 245 horsepower and 370 pound-feet of torque. Without meaningful competition from any domestic manufacturer, it was the most powerful production vehicle available from an American showroom. Ford called it a work truck. Nobody else called it anything at all. Ford removed the 460 from every passenger car and luxury vehicle between 1978 and 1979. The engine was too large for a market that had decided fuel economy was the only number that mattered. In the F-250, the F-350, and the E-Series van, there was nothing that could replace what the 460 did. The engine stayed. Ford added electronic fuel injection in 1983. The bore did not change. The stroke did not change. The cast iron block, produced in Ford's Lima, Ohio plant, and machined to tolerances shaped by a manufacturing culture that had spent 4 years building aircraft engines, ran through 3 decades of emissions regulation without a fundamental redesign. The 460 remained in Ford's F-Series through the 1997 model year. Subscribe to American Motor Files. This channel documents what American engineering actually looked like before the software took over. The 1997 model year was the last. 30 years of uninterrupted work truck service, from an engine that started its life in a Lincoln. Ford replaced it with smaller displacement designs and modern architecture. The farms that had run 460-powered F-350s did not immediately notice. The trucks were already there. They were already broken in. They were already trusted. There is no module in a 1989 F-350 with the 460 that determines when its service life is complete. There is no telematics system reporting its operating hours to a manufacturer. There is no dealer authorization required to pull the heads, replace the rings, and put it back to work. There is an iron block running the mechanical principles it ran when it left Lima, Ohio, and it will continue running them until someone makes a deliberate decision to stop it. The farms have changed. Some of the ground these trucks first worked has changed hands twice since they were new. The men who bought them are gone. Some of the farms themselves are gone, subdivided or sold, or converted into something the original owners would not recognize. The engines are still there. Ford built this machine from a manufacturing standard it did not create for civilian use and could not have planned for a farm. The engineers who carried that standard into peacetime never had a formal name for what they were doing. They were building to the only specification they had learned, a specification that came from a factory that had to finish one bomber every 63 minutes because the war did not stop for a bad casting or a missed tolerance or an engineer who needed another year to get it right. The Korean War gave one of those engines an extra year anyway. That engine stayed in farm trucks 2 years after it left passenger cars. The war that shaped the engineers came and went. The standard they carried into the field outlasted the war, outlasted the factories, outlasted the men who set it, and outlasted the farms that first put it to work. If this is the kind of engineering record American Motor Files is here to document, subscribe. There is more behind every pre-computer truck still running than the companies that built them ever said out loud.